Hello students, welcome to Spectra Education Academy. In this video, I am going to explain motion of the blocks connected by a string which is passing over the pulley. Yeah, motion of the block over a pulley. So let us discuss the first case. Say this is a pulley. The center and which is connected to taking a string which is connected to the rigid support, and this is the string. One end of the string is connected to body of mass m1 and other end of the string connected to body of mass m2. So pulley passes over, string passes over the pulley. Now, so taking free body diagram, weight of the first body acts vertically downwards, that is m1g. Similarly, weight of the second body also acts vertically downwards towards the center, that is m2g. Now, suppose one of the body is greater. One of the body greater means what? Mass of one of the body is greater. You take m2 greater than m1. Okay, so m2 greater than m1 means automatically m2 will try to come down with some acceleration. So therefore, now how tension favors and opposes. So let us say for the case of m2, since m2 is coming down, tension opposes its motion. There is only one string, so there is only existence of one tension. So tension opposes the motion of m2. At the same time, m1 will go up. Now tension favors m1, but its weight opposes. Now, for the case of m2, free body diagram. For m2. Okay, so its weight is now the applied force, but it is opposed by tension is equal to, when weight is slightly greater than tension, definitely body possesses acceleration. So that is like net force m2a. So you call this the equation 1. Now for m2, for m1 now, for m1, tension is the reason, but it is opposed by its weight. Now tension provides acceleration to the first body. This is equation 2. If you solve these two equations, you'll get equation of acceleration. Okay, solving these two. So this is tension with negative, tension with positive. You can cancel these two. So now you can write m2g minus m1g is equal to, both m1a and m2a get added, m1 plus m2 multiplied with a. Now, so take out common g from here. So a is equal to, so this is acceleration of both the bodies, m2 minus m1 with g 4 divided by m1 plus m2. Yeah, if you put this equation of acceleration, let us call this the equation 3. If you substitute this 3 in any one of the equation to get tension in the string, so therefore, let us substitute in the first equation m2g minus t is equal to M2 of, so this is going to be M2G minus M1G whole divided by M1 plus M2. Now, so let us expand this. So this is going to be M2 and M2 square G minus M1 into M2G whole divided by M1 plus M2. Now, so you are looking for the equation of tension. Okay, so this is going to be M2 square G minus M1 M2G whole divided by M1 plus M2 minus M2G. But remember, this is minus. If you cancel this minus, this entire quantity will have minus here, but this quantity will become plus here. So just for simplifying, after taking LCM M1 plus M2, now, so minus M2 square G will continue. Even M1 into M2 also will continue. Okay. So there is minus means this become plus. Yeah, because this entire minus is multiplied. Okay. Now M1 and M2 get multiplied. M1 with M2G plus M2 square G. M2 square G whole divided by M1 plus M2. So there is a cancellation here. So cancellation is plus M2 square G minus M2 square G. So the tension is 2M1 M2G by M1 plus M2. So this is the tension in the string. So there is one more string which is connecting center of the pulley and the rigid support. So therefore, you call this as T2 now. So when you talk about tension in the string connected to the pulley and rigid, so connected between the pulley and center of the pulley and rigid support, so T2, so you make these two are T1s. Yeah. So now this is going to be T1 in that context. So therefore, T2 is equal to 2 times of T1. So 2 into 2M1 M2 G by M1 plus M2. Yeah. You can even substitute the same acceleration equation. In equation 2, you'll get the same tension equation like this only. So this you can expect numerical on these two steps. Even on this also. Yeah. So let us discuss another case. It is the same. Suppose let us say this is the pulley. So center of the pulley and the rigid support are connected by a string. The string passes over the pulley. So there is a body of mass M1 connected left side, and there are two bodies connected right side. So let us say this is the body of mass M2, and there is another body connected. This is going to be M3. Now, so first let us list out the forces acting. So first thing is weight of M1 acts vertically downwards. This is M1G. Similarly, weight of M2 also acts vertically downward. This is M2G. So this is going to be M3G. Now, so let us list out how the tensions will be. So this is going to be T1. This is also going to be T1. Now there is one more string here. So in case of M2G, T2 favors. In case of body M2, T2 favors its motion. Whereas in case of body of mass M3, T2 opposes. So now let us list out the free body diagram equations. So for M1, so in case the sum of M2 plus M3 is greater than M1, so definitely these two bodies will come down with acceleration and this body will go up with acceleration. So therefore, T1 is the reason for the motion of M1 upwards, but its own weight opposes. This is going to be M1A. Then for M2, T2 as well as its weight favors the motion, but its motion is opposed by T1 is equal to M2A. Now for M3, its weight favors, but T2 opposes its motion. M3. So therefore, once you get the equations, these equations, so you can proceed according to the question. So maybe question to ask to find out T1 or acceleration or inertia. So just modifying these equations, you will get the result. Now, moving to another case, let us say a block of mass M1, which is on the top of the table. So there is a pulley here. So a string connecting the two blocks. So M2 is connected another end of the string. Now let us list out the forces. M2G acts vertically downwards. Then tension acts upwards. Here tension favors the motion of M1. So weight of M1 does not contribute anything to the motion of to its motion. Then, so now let us write the free body diagram. First let us start with M2. Its weight is the reason, but it is opposed by tension is equal to M2A in case M2 is greater. M2 is greater than M1. Of course, there will be friction questions also. Now, so therefore, this is for the case of M2. Now, for M1, tension favors, you don't have any other force to oppose the motion. So tension is the reason for its motion. It is M1. So you can, if you solve this, you can get the common acceleration. Tension get cancelled. So therefore, M2G is equal to, take out common A, M1 plus M2. So therefore, acceleration is equal to M2G divided by M1 plus M2. Okay, so you can expect a simple question based on this. If you substitute, let us say this is equation 1, this is equation 2. Yeah. So if you substitute this 3 in 1 or 2, so better directly to get the answer, substitute in equation 2. So this is M1, A is replaced with M2G by M1 plus M2. Yeah. Let us discuss another case. Suppose 3 bodies are taken and 3 bodies are connected with 2 pulleys. Let us say a body of mass M2 is on the table and so 2 pulleys are taken. So this is a body of mass M2. Right. So here are the 2 bodies. This is of mass M1. Now there is another string connecting M3 and M2. Now, so in case if you take M3 greater than both M2 and M1, so therefore definitely, so you can expect M3 to come down with acceleration. So now let us list out the tensions. Suppose let us say this is the first string, you call it as connecting M2 and M3. So tension opposes, T1 opposes the motion of M3, but T1 favors the motion of M2. So when M3 is coming down with acceleration, M1 will go up with acceleration, up. So therefore, here tension T2 favors, but here tension T2 opposes the motion of M2. So but T1 favors. So therefore, so now weight of M1G acts vertically downwards. Similarly, M3G act vertically downwards. So here T2 is opposed by weight of the body of mass M1. Now for M1, for the case of M1, yeah. So T2 favors, but its weight acts vertically downwards, opposes. This is going to be M1. Now for M2, assume that M2 is going from left to right. So T1 favors, but it is opposed by T2 is equal to M2 here. Now for M3, its own weight is the reason to move down, M2G, but the T1 opposes, this is M3. So once you write these free body diagram equations, so you can find out the any value, any physical quantity, either acceleration or T1 and T2. So once you are able to write these equations, you can find out any physical quantity according to the question. So the equation 1, 2, 3. If first equation and third equation are solved, let us see. So it is going to be T2 minus M1G. Okay, let us don't change any sign, just let us add directly, plus M2G minus T1 is equal to A of M1 plus M3. Now, so let us write T2 minus T1 is equal to, so take other side. This is G you take out common. It is going to be, okay, instead of taking other side, now you write one more step here. G you take out common. So it is going to be minus G. So this is going to be M1 minus M2. So this equation remains same, A of M1 plus M2, M1 plus M3. Yeah. So now you take this step. You take T2 minus T1, entire step is the other side and get acceleration this side. So minus G will continue. M1 minus M3. M1 minus M2. Okay. Then minus A. M1 plus M3 is equal to T1 minus T2. Yeah. So now this we call this fourth equation. Compare 4 and 2. Yeah. So if you compare 4 and 2, so equation 2 has M2A is equal to minus G M1 minus M2 minus A of M1 plus M2. M1 plus M3. So take this entire step left. So therefore, so once again you can take out common A of M1 plus M2 plus M3 is equal to minus, otherwise if you don't want to write minus, better directly write out M2 minus M1 with the G. So acceleration equation is G of M2 minus M1 whole divided by M1 plus M2 plus M2. So substitute this equation 5 to get either T1 or to get either T2. So let us discuss another case here. Suppose let us say a body of mass M1 is on the inclined plane and there is a pulley connected at the top end of the inclined plane. So therefore both M1 and M2 are connected with a string. So this is of M2, this is of M1. Now first taking the resolution, whenever body is on the inclined plane, its weight acts vertically downwards. This is M1G. So this is theta. Now, so there will be normal reaction here. Suppose if you extend this, there will be theta here. So resolving weight M1G into two components. So one of the component M1G sin theta acts downwards along the inclined plane. So another component M2G cos theta, it does not play any role for the motion of the block M1. Now suppose if M2 is greater than M1, so what you can expect is you can make this moves with acceleration down A and M1 will go up with acceleration. So therefore tension favors the motion of M1, whereas tension opposes motion of M2. So for M2 first, its weight M2G acts vertically downwards. So its weight is the reason for its motion. Opposed by tension is equal to M2A. Next, whereas for M1, tension is the reason, but it is opposed by, of course, if there is a friction case, you can extend that for that also. We'll discuss that in detail in chapter friction. So M1 G sin theta is equal to M1U. So if you solve these two equations, tension get cancelled. Therefore, you'll get take out common G. So this is going to be M2 minus M1 sin theta is equal to acceleration common out M1 plus M2. So therefore, A is equal to G of M2 minus M1 sin theta whole divided by M1 plus M2. So this itself may be the question, or maybe some numbers are given in place of the physical quantities. So letters are physical quantities here. So this is the equation for acceleration. Now if you substitute this equation in any one of the equations, you'll get the tension equation. So let us check. Therefore, you call this equation 3. Okay, any one of the equation, look at this. So you take this as equation 2. So let us substitute 3 into for tension. So T minus M1G sin theta is equal to, so this acceleration is multiplied to this quantity M1 of, so let us write this is M2G minus M1G sin theta whole divided by M1 plus M2. Okay, so first you expand this M1 M2G minus M1 square G sin theta whole divided by M1 plus M2 plus taking this quantity right side M1G sin theta. So other side you are left with T. Now LCM will be M1 plus M2. So directly you can write M1G, M1 M2G minus M1 square G sin theta. Now, so let us multiply M1 alone with this quantity. So this is going to be M1 square G sin theta M1 square G sin theta plus M1 M2 G sin theta. So whole divided by M1 plus M2. So what you can cancel is these two quantities you can cancel. So therefore you are left with, you can take out common M1, M2, even G also. So this is going to be 1 plus sin theta whole divided by M1 plus M2 is equal to tension. So this itself may be directly question. Yeah, this is the equation of tension. Even you can expect two blocks moving on inclined planes. Inclined planes are given two sides. Therefore, like this. So this is inclined plane one side. This is the inclined plane other side. So this is the horizontal plane surface connecting two side inclined plane. Yeah. Okay. So here is the block of mass m1. Now let us don't say theta 1, theta 2 equal, because this inclined plane with vertical and this inclined plane with horizontal and this inclined plane with horizontal may be different. Thetas are may be different. You continue to have theta 1 and theta 2. So therefore, this is of mass m2. So first, its weight acts vertically downwards towards the center. Similarly, weight of the second body also acts vertically downwards towards the center. Now these two are connected by a string which is passing over the pulley. Yeah, so this is motion of the two blocks on double inclined plane. Now here, suppose if you take, and once you resolve weight of both the bodies into two components, this is going to be normal reaction. So m1g cos theta, so does not contribute anything to the motion. Its weight, another component m1g sin theta, theta 1. So therefore acts towards the bottom of the inclined plane, along the inclined plane. Okay. So similarly, so this is the normal reaction. Next, its weight acts vertically down. Its weight acts along the inclined plane. Component of weight m2g sin theta 2. Yeah. So therefore, now suppose if you take m2 greater than m1, yeah. So then you can expect m2 to move down with acceleration. So m1 moves up with acceleration. So therefore here tension opposes the motion of m2. Tension favors the motion of m1. So therefore for m2, first let us begin with m2g sin theta 2. This is sin theta 2 favors, but tension opposes, is equal to m2a. Similarly for m1. So therefore tension favors m1. m1g sin theta 1 is equal to m1a. If you solve these two, so you can cancel tension and tension. So therefore, take out common g. So m2 sin theta 2 minus m1 sin theta 1 is equal to a of m1 plus m2. So equation of acceleration will be g of m2 sin theta 2 minus m1 sin theta 1 whole divided by m1 plus m2. So this is the equation for acceleration. So if you substitute this acceleration equation in 1 or 2, you will get the equation of tension. Students, in the next video, I'll continue a few more cases of connected bodies. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.